All right. So, I'm going to be explaining this problem. Basically, starts off with a spring mass vertically being held up. So I'll call this, uh, sorry, y max in terms of height. Um, and it's going to have a equilibrium position where the m and or the force downward is the same as force upward. So I'll call that equilibrium. And then at the bottom, it's going to be fully extended, and this will be y min, or you can think of it as an max. It doesn't really matter. I'm not going to set up axes. So basically, the important part here is because of the conservation of, I guess you could say, forces here. These two distances, which I'll label with A, are actually going to be the same since it's simple harmonic motion. It's going to be bouncing down basically as far as it started up here. And so that means these two distances are the same. So let's look at the first question. So it says, show it exerts an upward force of 2 mg at its lowest point. So if we think of force, right, upward force, we know for a spring that's negative kx. But in this case, what is x? X equals 2a, right? So k 2a, because a is basically the distance that traveled times 2, or 2 times the distance of travel, whatever, right? And so if we think about it, at the equilibrium point, mg is pulling down, and then negative ka is pulling up. So that must mean at the bottom, negative 2, sorry, positive 2 mg, if this is positive, is pulling down, and negative ka 2 times that is pulling up. So that's basically why the upward force is 2 at its lowest point. So then if the spring has a constant of 10 and it's a 0.25 kilogram mass, find the amplitude of oscillation. So basically, the amplitude I'll say is A, right? And so yeah, so basically set up a force equation. So negative Ka, we know at equilibrium, that's going to equal mg, because basically this is just the distance it falls from being held up. It's going to fall to an equilibrium distance and fall past that and then go back up to it. Basically, if we look at this distance is going to be our equilibrium. So, or amplitude, not equilibrium. So we're going to solve for A. So A equals negative mg over k. This equals 0.25 times 9.8 over 10, which is um, A equals, and it's going to be in either direction, 0.245 meters. So that basically means it's bouncing up 0.245 meters and bouncing down from this position. So now it wants us to find the maximum velocity. So this might be a little scary, but if we think about it, we have some of our relationships with angular frequency, sometimes known as angular velocity. And this is we know is equal to k over m, k being spring constant, m being mass because of the whole cosine thing. I won't go through that now. But if we think about it, we also have a relationship between v and w, which is v is wr. But if we think about a circle with a radius of r, if we're having harmonic motion with our waves here, that was a really bad wave. We look at what the amplitude is, the amplitude is actually equal to r. So A is actually equal to r. So it's saying what is the maximum velocity? In this case, the spring's going to start pulling up. It's going to basically be in, not in free fall, but the spring's going to start slowing it down once we've reached this equilibrium position. And until that, it's going to be accelerating positively. So the acceleration, no, the position will look like this. So we basically want it before, sorry, velocity will look like this. and we want it before the velocity starts slowing down, right? So we want to find the maximum velocity, which is that point. So to find that, basically we know that that's going to be at the equilibrium position where it has fallen a distance of a in either direction or gone up a distance a from the y minimum. So basically, to relate these two equations with velocity, if we sub in this for w, we get v equals root k over m, and we know that r is the same thing as amplitude. So we get root k over m a, which is root 10 over 0.25 times our amplitude, which we calculated in the last slide to be 0.245. 0.245. Putting this into a calculator, square root 10 over 0.25 times 0.245 equals 1.55 meters per second, which is going to be your final answer. And that's basically it for this video. Comment if you have any questions. Thank you.